All right, so today we're going to be working with solving a different way. So we've talked about a couple of different ways to solve quadratic equations. Can somebody tell me a way we learned how to solve a quadratic equation? Okay, great. Completing the square is one way we've learned. And you can actually always use completing the square. So I'm going to put an A next to this. You can always use it, but sometimes it's just not the easiest way. All right. So yeah, you can always use it, but not always the easiest. What's another way we've learned? Yeah. Factoring. Yep. Factoring, we can sometimes use, depending on the problem. You cannot always factor. Okay. Anything else we learned how to solve a quadratic equation by? We can do square roots of it, both sides sometimes. So that's another thing we can use sometimes. The fourth way we're going to learn today is called the quadratic formula. So quad form, we'll abbreviate that. So the quadratic formula is also going to be another one that you can always use to solve a quadratic equation. So the quadratic formula, our learning goal for today is we want to be able to solve equations using this quadratic formula. And we want to look at something called the discriminant. So that's going to be a new vocabulary word for you, discriminant. And we're going to use that to determine the number and types of solutions. We also want to be able to solve some real life problems with quadratics. All right, so first of all, what is the quadratic formula? Well, it's right down here. As long as we have an equation in this form, ax squared plus bx plus c equals 0, our solutions for x are always going to be, and I'll try out my singing skills here, but it's going to go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If that helps, use it. If not, just memorize it. Okay? So this is a way that we can solve a quadratic equation always. Now, the discriminant. The discriminant is this value that's under the radical. See how under the radical we have this b squared minus 4ac? That's what we call the discriminant, right there. All right, so why do we care about the discriminant? Well, if we look at the discriminant and it's greater than 0, so what does that mean? Greater than 0 means it's positive, right? So if that discriminant, it has a positive value, that means we're going to have two real solutions. Also means we would have two x-intercepts if we were to graph the function. If that discriminant, that b squared minus 4ac is equal to 0, that means we're going to have one real solution and just one x-intercept. So that's when it's equal to 0. If we have that discriminant that's less than 0, meaning it's negative, we're going to have two imaginary solutions and no x-intercepts. All right, let's take a look at how this is all connected to what we've been doing. What do we always have to get this set equal to? 0. So I have to subtract my 18. And we're going to go ahead and it says to find the discriminant. So we're going to do that. So we have to know A is the coefficient of x squared, B is the coefficient of x, and C is the constant. So there's what A, B, and C are. We're now going to calculate that discriminant. The discriminant is b squared minus 4ac. So what is negative 7 squared? So we're going to have 49 minus 4 times 1 times negative 18. Do you guys know what 4 times 18 is? Double 18 and then double it again to multiply by 4. 72. So we're going to be doing 49 plus 72, and I'll tell you that's 121. All right, so our discriminant is 121. That's positive, right? So that means then that if we have a positive discriminant, we should get two real solutions. Two real zeros. Zeros and solutions mean the same thing. All right, now let's go ahead and use the quadratic formula on this, okay? So to solve it, x equals negative b. So what's the opposite of negative 7? So we're going to have 7 plus or minus the square root of, what did we get for that discriminant? 121 all over 2 times 1, which is 2. So now we're going to have 7 plus or minus, what's the square root of 121? 11 all over 2. What is 7 plus 11 and then divided by 2? Right, so one of our solutions then is 9. And then I have to do 7 minus 11, which is negative 4. What's negative 4 divided by 2? Negative 2. Those are going to be our two solutions for x. Like I said, quadratic formula always works. These are our two real zeros. These would also be our x-intercepts, 9 and negative 2. If I wanted to, I could type that into my calculator and look at it. Was it necessary to use the quadratic formula? Let's go back and look. Are there numbers that multiply to be 18 and subtract to be 7? Yes or no? What are the numbers? And what those are solutions? So we did not have to use the quadratic formula on that problem, but we did. So it's fine. We'll just stick with it. But that's what we want to check for first, usually, is whether we can factor. All right, so now let's do it first on this one. What do our numbers have to multiply to be? And they have to add to be 4. Numbers that multiply to be 6 are 6 and 1, 3 and 2. Do any of those multiply to be 4? Or I'm sorry, add to be 4? No. So therefore, I could use completing the square, or I can use the quadratic formula. We're trying to practice with the quadratic formula, so that's what we're going to use. First thing we're going to find is that discriminant. We have to do b squared. So what's b squared? 16 minus 4 times a times c. Figure out what that is. What is it? This is 16 minus 24, so negative 8 is what you should have gotten for the discriminant. So what does that tell us about the types of zeros we have if we have a negative discriminant? Two imaginaries. So we have to have two imaginary zeros or solutions. What should it also mean? That we have what? No x-intercept. I happen to have this typed in for us. Let's take a look at it. Here's that function. Does it have any x-intercepts? No. All right. Let's finish this now with the quadratic formula. You have to memorize it. Negative b plus or minus the square root. We already did the discriminant. I'm just going to call this discriminant. All over 2a. So what is the opposite of b? Negative 4 would end up being 4 plus or minus the square root of, that discriminant was negative 8 all over 2 times 1. We have to simplify this square root of negative 8. What numbers multiply to be 8? 4 and 2. And what do we do when we have a negative under the radical? Put an I. So we're going to have x equals 4 plus or minus, I have to have an I, and what's the square root of 4? So this is going to be 2i radical 2 all divided by 2. Here's the way we simplify this. These are two terms. So this term has to get divided by 2, and this term has to get divided by 2. So what's this term going to be when I divide it by 2? 2. I also have to divide this term. All of this together is a term. So when I divide this, I divide the parts that are alike. So I only divide this part. So what am I going to have left then? There you go. That's going to be the solutions to that equation. Okay? I also could have completed the square here, and it might have even been a little bit easier. Why do I think it might be easy to complete the square? What type of number is this right here? Yeah, but also if I take half of 4, don't I get 2 and square it is 4? That's pretty easy math. But if this had been a 3 or a 5, is it easy to take half of 3 and 5? No, so if that's even, it might be pretty easy to complete the square. All right, guys, let's do one more here on this part. Okay, so right here, I want you guys to figure out what the discriminant is. So we have to do b squared minus 4 times a times c. Anybody have it? What is it, Sam? Yep. So our discriminant is 0. So what does that mean then when the discriminant is 0? So we should get one real solution. Now, I can use the quadratic formula if I want, but let's check. Are there numbers that multiply to be 9 and add to be 6? 3 and 3? Okay, so let's do it this way then. We put our x and our x. What are those numbers you just told me? 3 and 3. We need these outers and inners to give us a negative 6. So what do I need the signs to be? Negative. And so what's our solution? What minus 3 is 0? And see how we got one real solution there? Instead of getting two reals, we got one real solution on that. All right, guys. What about this one? How can I start it? Do what to it? Divide by 4. Ugh, I don't know if I want to. Let's divide by 2. And because it's equal to 0, I'm allowed to just divide every term by 2. If it's equal to y, I can't do that. But if it's equal to 0, I can. All right, let's check it out. This has a coefficient here. So I can't just say, are there numbers that multiply to be 9 and add to be 6? I have to say, are there numbers that multiply to be 18 and add to be 6? Because I have to do 2 times 9. Numbers that multiply to be 18. 1 and 18, 2 and 9, 3 and 6. Do any of those add to be 6? No. I don't want to go all the way through this one, but let's just find the discriminant. The discriminant is going to be b squared minus 4 times a times c. Since we're not finishing this problem, I just want to know, is this going to be positive or negative on the discriminant? How do we know it's negative? What's this going to be? 72. So if I do 36 minus 72, wouldn't that end up being a negative? And so what types of solutions should this have? Two imaginary. Will it have any x-intercepts? No. All right. The other one I do want to do is down here, number 6. All right, what do we have to get this set equal to? So we're going to have x squared plus 8x minus 3. Let me pause there for a minute. I want to encourage you to skip steps as long as you don't make mistakes when you do it. Can you guys understand how I got this? Okay, so let's check to see if we can factor. Are there numbers? There's no coefficient there. So are there numbers that multiply to be 3 and subtract to be 8? No. So let's go ahead and do this. We're going to find the discriminant. We do b squared minus 4 times a times c. Figure that out for me. Who has it? All right, Sam, what's that discriminant? Yes, so we have to do 64 plus 12. So that is 76 on that discriminant. Now, to find the solution, we're going to have to go to this right here. We have to do the opposite of that, plus or minus the square root. This is the discriminant. That's what goes under here, all over 2 times a. We need to know if we can simplify this. So a perfect root would be 4. Is that divisible by 4? I think it is. Yeah. So 76 is divided by 4. So this is going to be 4 times 19. So what's my exact answer going to be then? 8 plus or minus what? How do I simplify it? That's 4 times 19. 2 radical 19, right? Because I have to take the square root of the 4. And so our exact zeros, remember what I told you about simplifying something like this? Do you know what it is? Good job. Those are going to be our 2 exact solutions. Now, on a test, you might also be asked to find the approximate solutions. Exact solutions have radicals in them. Approximate solutions are when we plug these into our calculator. Try it out if you have your calculator handy. Type in 4 plus the square root of 19. Okay? So this, I'm going to have to round this to what? 8.36. So that's going to be an approximate solution. Guys, watch this. Instead of having to type in 4 minus radical 19, go up here and grab it and push enter. And now just change that plus to subtraction and get your other answer. Save yourself a little bit of time. So our other approximate answer is negative 0.36. So these are approximate answers. These are called exact answers here. Questions on that? All right, let's go to this last problem. A baseball player hits a foul ball straight up in the air from a height of 4 feet off the ground with an initial velocity of 85 feet per second. Here's the formula we're going to use, and we've seen this formula before. Negative 16 never changes. T is our time. What do you think V sub O stands for? Velocity at time 0. So this is our starting velocity. There's time again. So what do you think this is? Our starting height. So all it says is write the quadratic function that represents the height of the ball t seconds after it hits the bat. Well, that's going to be h of t equals, can you think of how this is going to look? Plus what? 85, just 85? Don't forget the t, guys, plus 85t. And then plus what? Can anybody think of why this 4 makes sense for this problem? Rachel? I like the batter's hitting off the ground. Right, that's where the bat is, off the ground, 4 feet high. Okay. So there's the answer to that. Write an inequality to describe the time interval for which the ball is at least 110 feet off the ground. Well, that would mean that I want this function, if it says at least, what does that mean I want it to be? Greater than, just greater than, or greater than or equal to 110. So that would be the inequality we would write to explain that. We want the height to be greater than or equal to 110. That's all we have to write for that. We don't even have to solve it. The catcher catches the ball 6 feet from the ground. How long is the ball in the air? Well, let's go to our calculator. Let's type this in. Let's just hit graph and see what happens. Okay. I need to change my window to see up higher. I'm going to go kind of big. Let's try 200. That might be too much, but we'll see. Nope, that's fine. Okay, so the catcher catches the ball 6 feet from the ground. So what's it telling me then? What do I want to be 6? The time or the height? The height. So I'm going to go to y equals, and I'm going to say I want y to be 6. Now I'm going to hit graph again. Is the catcher going to catch the ball at this time or at this time? Right. The second one, right? I've never seen a catcher catch a ball on the way up, right? They always catch it on the way back down. So we're trying to find this. And what is that going to be? Second trace calculate the intersection. Yeah. And to find the one over there, I have to be kind of close to it. So enter, enter, enter 3 times. So 5.29 seconds. All right. So what's the formula for the discriminant only? Good. B squared minus 4AC. And then we just have to add on the other part when we're solving. We have to add on that negative B over 2A part. Does that seem familiar, negative B over 2A? Where did we use that before? Standard form finding the vertex, right? Isn't the vertex in the middle of a parabola right here? And so then if I go left and right, that same amount, that's where the x-intercepts end up being. So we're going to get into that a little more in the future. All right, guys, we're going to stop there and